All right, the other part that I want to do is a couple of examples using inverse, direct, and joint variation. So here we'll do examples 9 and 10 because those are direct and inverse, and then we'll do 9, 10, 11, and then we'll move to number 13 for joint. All right, so notice these are the exact same problems. If y varies blank as x and y is 12 when x is 8, then what is y when x is 24? The only difference that I'm going to put here is that this one is going to vary directly, and this one's going to vary inversely. So this alone will determine the x values that I get in the end, two different answers. So right here, for varies directly, we know we're going to use the equation y equals a times x. In order to find a, we need to divide, direct is divide, we need to divide the two numbers they give us because we plug them in. So we would do 12 equals a times the 8. And in order for us to solve for a, we divide 8 by both sides. So a equals 12 divided by 8 is 1.5. Or you can write it as 3/2, however you want to write it. All right, so my equation would be y equals 1.5x, because we got 1.5 to be the a value. So the second part of this says find y when x is 24. So all we're going to do is take 24 and plug it in for x and multiply that by the 1.5. 1.5. So y equals 1.5 times 24 gives us that y is 36. Right, but that's for a direct variation equation. For an inverse variation equation, we set it up opposite. So here, instead of y equals a times x, we're going to set it up as y equals a divided by x. But we're still going to use these two numbers to plug in for the x and the y. For inversely, we're going to end up multiplying these two in order to find a, because when we plug it in, so the 12 and the 8, in order for us to solve for a, so a is here, we need to multiply both sides by the 8. So multiply this by 8 and multiply this by 8. So a equals 8 times 12 is going to be 96. So my equation is y equals 96 over x. So here's the constant of variation that we found, and now we use it to find y when x is 24. So now all we're going to do is do 96 divided by 24 and then get our y value. So 96 divided by 24 is going to give us that y is 4. So again, same numbers, but the direct and inverse variation makes it completely different answers when you solve it because of the equation you initially set up. All right, so 10 is exactly like the second one here. So I'm going to skip 10. I do want to do a word problem. So let's do 11, and then we'll jump to 13. So looking at 11, the key word here is that it says in physics, the current for a circuit is inversely proportional to the resistance. If the current was 18 when the resistance is 2.4, then what is the current when the resistance is 3.2? So here, we're going to set this up as I equals, inversely means that we have to divide by R. So we need to figure out what this number is in the numerator. We need to figure out that constant of variation. So we're going to use the two numbers that they give us. The current is 18 when the resistance is 2.4. We're going to use those two to figure out A. So 18 equals A divided by 2.4. So to solve for A, we multiply both sides by the 2.4. So 18 times 2.4 is going to give us that A equals, what is that number? 43.2. So my equation is I equals 43.2 over R. So now the second part says use this value, use this equation to find what the current is when the resistance is 3.2. So all we're going to do here is plug in 3.2 into the resistance. So I equals 43.2 divided by 3.2. And when we divide it, we get that I is 13.5. And it's whatever units it says. It doesn't give us units, so we just label it units. All right, so the key for the trick for inverses is that you multiply the two numbers they give you first, and then whatever value they're looking for, you divide that number by the A value that you got initially. And this one is pretty much the same thing. Inversely, we're going to do the same thing there, but that one you can work out yourself. All right, the final part is joint variation. So I'll explain what joint variation is here, and then we'll do an example with that one. So joint variation, it's a combination. Here we have multiple things that vary directly. So it's still going to be a direct variation, but since it's two variables, A is still your constant of variation. So constant of variation. The X and the Y are your variables. So we need to figure out both of those, or we're going to be given both of those values to use to find A. So right here, it says the variable Z varies jointly with X and Y. So I'm going to start off by writing Z equals some number, which I don't know what it is, so I'm going to call it A, times XY. So the first thing I need to do is find A. In order for me to make an equation, I need to find A. So I'm going to use these values to solve for A. When Z is negative 44, X was 4, and Y is negative 1. So in order for me to find A, I multiply these two together first, and then I'm going to divide it to the other side. So negative 44 equals A times negative 4. And then I just divide both sides by negative 4. So A equals 11. So my equation, all I do is take the 11 and replace it with A. So Z equals 11XY. So again, Z depends on both of these. It's a joint variation here. So now we want to find Z when X is 6 and Y is 3. So Z equals 11, because that's the constant of variation that we found. And then we're going to multiply 6 here and 3 here. So times 6 times 3. So 11 times 6 is 66. And then 66 times 3 makes 198. All right, so most formulas, if you look ahead at the bottom, in everyday situations, depend on more than one thing. So here, if we looked at the bottom, notice these, formula for volume depends on multiple values. This one depends on both of these. So it's not always just one variable that the dependent relation or that the independent variable depends on. So you need to know how to deal with multiple variables. All right, so then you're going to complete the other ones using your notes. And if you need to come in for tutorials, I will be here as well. Stop this thing.